Hello, welcome to Lesson 6, Masterclass in Algebra for JSS1 to JSS3. Our topic today is algebraic fractions. And by the end of this lesson, students should be able to identify algebraic fractions, number one. Number two, they should be able to simplify algebraic fractions. Number three, students should be able to factorize before counseling common factors. Number four, students should be able to add and subtract algebraic fractions. And lastly, number five, students should be able to multiply and divide algebraic fractions by the end of this lesson. So let's look at the meaning of an algebraic fraction. What is an algebraic fraction? An algebraic fraction is a fraction that contains one or more algebraic expressions. So an algebraic fraction, or rather a fraction that contains one or more algebraic expression, is referred to as an algebraic fraction. Example, x over 5 is an algebraic fraction. 3x over 7 is an algebraic fraction. X plus 2 all over x minus 3 is an algebraic fraction. X squared minus 9 all over x plus 3 is also an algebraic fraction. So why are they algebraic fractions? Why are they not just called fractions? They are called algebraic fractions because they contain algebraic expressions. That's why they are referred to as algebraic fractions. The expression at the top of the fraction is the numerator, while the expression under the fraction or the bottom of the fraction is referred to as the denominator. Example 1. Simplify 12x all over 18. Now this is an algebraic fraction because it contains an algebraic expression. So now we are asked to simplify the expression. The numerator is an algebraic expression, while the denominator is a constant. So how do we simplify this type of expression? Solution. So the method we are going to use here is cancellation. So we are going to cancel out the common factors of 12 and 18. Therefore, 12 can also be written as 3 multiplied by 4 multiplied by x all over 18 can also be written as 3 multiplied by 6. Now 3 will cancel out 3 and we're going to be left with 4x all over 6. We can also rewrite 4x over 6 as 2 multiplied by 2x all over 2 multiplied by 3. 2 will cancel out 2. Therefore, 2x all over 3 is the resulting expression. Now we cannot simplify this expression more than this, so we're going to leave it like that. 2x all over 3 is the simplified version of 12x over 18. Example 2. Simplify 15a all over 25. 15a can also be expressed as 3 multiplied by 5a all over 5 multiplied by 5. Now 5 will cancel out 5. Therefore, the resulting expression is 3a all over 5. Example 3. Simplify x squared minus 9 all over x minus 3. In this example, we are going to factorize before we cancel out. In the first example, we use cancellation to simplify the algebraic fraction. But in this example, we are going to factorize before cancelling out. So there are situations where you come across algebraic expressions that you have to factorize them first before you cancel out if you are asked to simplify them. So in this instance, we are going to do that. So x squared minus 9. So x squared minus 9 can also be written as x squared minus 3 raised to the power 2 all over x minus 3. Now you can see that the first expression, the numerator, is a difference of two squares. Now in our previous lesson, recall that a squared minus b squared is equal to a minus b, a plus b. Therefore, the difference of two squares here, x squared minus 3 squared, can be expressed as x minus 3, x plus 3, all over x minus 3. So we have successfully factorized the numerator of the original algebraic expression. Now the next thing we are going to do, we are going to cancel out common terms. So x minus 3 is here in the numerator, x minus 3 is also the denominator of the algebraic fraction. So we are going to cancel out these two common terms. So x minus 3 cancel out x minus 3. So the simplified form of this algebraic expression is x plus 3. Look closely at this example, example 4. Simplify x squared minus 16 all over x minus 4. Now, x squared minus 16 can also be expressed as x squared minus 4 raised to the power 2 all over x minus 4. So this algebraic expression can also be expressed this way. Now we can see that the numerator is a difference of squares. So, and we know that the formula for the difference of two squares is equal to a squared minus b squared, which is equal to a minus b, a plus b. So if we apply this formula here, the numerator is going to be expressed as x minus 4, x plus 4, all over x minus 4. So we cancel out the common terms, and the simplified version is x. Example 5. Algebraic fractions where the denominators are the same. The rule is that you should add the numerators. And because the denominators are the same, the expression becomes 5 all over 2x plus x, which is equal to 3x all over 5. Same thing applies to example 6. The denominators are the same. Therefore, the expression is 3a plus 2a all over 7, which is the same thing as 5a all over 7. This problem can also be solved in a different way. Now, you can do it this way. You can look for the LCM of the denominators. And the LCM of the denominators, 7 and 7, is 7. Right? The LCM is 7. Now, 7 divided by 7 is 1. 1 multiplied 3a will give us 3a. Bring down the positive sign. 7 divided by 7 is 1. 1 multiplied by 2a is 2a. So we are still going to arrive at the same answer. So you apply this method when the denominators are not the same. Let's say you have 7 and a different number here, 5. Now you can look for the LCM of 7 and 5, which is 35, and then use this method to simplify the algebraic fraction. But when you come across an algebraic fraction where the denominators are similar, just add the numerators and simplify. Example 7, subtraction of algebraic expressions. So simplify 7x over 9 minus 2x over 9. In this example again, the denominators are similar, they are the same. So what we are going to do here, we'll apply the method we used in addition of algebraic fractions. We are going to, since we have a common denominator, the expression becomes 9 all over 7x minus 2x. So if the denominator is the same, if the terms are the same, you subtract the numerators. If the denominators are the same, you subtract the numerators. Therefore, 7x minus 2x is equal to 5x all over 9. If you use the other method, where you have to look for the LCM of 9, you still arrive at the same answer. The LCM of 9 and 9 is 9. 9 divided by 9 is 1. 1 multiplied by 7x is 7x. Bring down the negative sign. 9 divided by 9 is 1. 1 multiplied by 2x is 2x. So you are going to arrive at the same answer. So my suggestion is that you use this method when you have different denominators. When the denominators are not similar. But when the denominators are similar, just subtract the numerators. Example 8, multiplication of algebraic fractions. 2x all over 3 multiplied by 6 all over 8. So when you have this type of expression, what do? You multiply the numerators together, then you also multiply the denominators together. So this expression will now become 2 multiplied by 6 is 12. Then we have 12x all over 15. So after doing that, you can now simplify. You can simplify the expression. 12x all over 15 can be expressed as 3 multiplied by 4. We will still arrive at the same thing. Okay, let's say 3 multiplied by x all over 3 multiplied by 5. Therefore, 3 will cancel out 3. The expression becomes 4 all over 5. So this is the simplified version. Example 9, we're going to do the same thing. 5 multiplied by x is 5x all over x multiplied by 10, 10x. Okay? So in this expression, what we cancel out? This expression is going to be 5x all over 10x is equal to 1 all over 2. X will cancel out x. 5 will cancel out 10, 2. 5 will cancel out itself, 1. Therefore, the expression is 1 all over 2. Example 10, division of algebraic fraction. So when you come across this type of fraction where 3x all over 4 is dividing 6 all over 5, what do? So this expression can also be expressed as 3x all over 4 multiplied by the reciprocal of 6 over 5, which is 5 all over 6. And so we can use or apply the method we used in multiplication of algebraic fraction by multiplying the numerators together and then multiplying the denominators together. Therefore, 3 multiplied by 5 multiplied by 3x is 15x all over 4 multiplied by 6 is equal to 24. Now, 15 and 24, do they have any common factor? 15 is 3 multiplied by 5. 24 can also be expressed as 3 multiplied by 8. 3 multiplied by 8 is 24, therefore 3 can cancel out 3. So 3 cancel out 3, the expression is 5x 5x all over 8. Now remember this rule when you are solving algebraic fractions. If you have x plus 3 all over x. Now if you have this type of expression and you are asked to simplify it, x plus 3 all over 3. You cannot do this. You cannot cancel out 3. You cannot say 3 cancel out 3. This expression here is x plus 3. So it is not right for you to say 3 cancel out 3. It's impossible. So this expression is still x plus 3 over 3. That's the simplified form. Or if you have an expression like this, x plus 3 all over x, and you're asked to simplify this. This expression cannot be simplified more than this. This is x plus 3 over 3. X cannot cancel out x. If you do this, it is wrong. You can't cancel out x plus 3 all over x. You can't. But if you have an expression like x multiplied by x plus 3 all over 3. Now this x outside the bracket is multiplying the terms inside the bracket. So because it is multiplying, you can cancel out x. So it is a rule, you have to remember it. Or when you have 3 multiplied by x plus 4 all over 3, or all over 6. Now you can cancel out 3, 1, 3, 2. Therefore, x plus 4 all over 2. But you cannot do 4 divided by 2. It's wrong. So you have to leave x plus 4 all over 2 as it is. So keep that in mind. So when you get to this part of the video, pause and do the assignments. Part A is simplification. Question number 1 to 4. Simplify the algebraic expression. Part B, you have to evaluate. Question number 5 to 8. Part C, you have to simplify completely. Question number 9 to 10. After answering the questions, send the answers to my WhatsApp number or send it to the comment section in my YouTube channel. My WhatsApp number once again is +2347007006845. And don't forget, like the videos in my YouTube channel, subscribe to my YouTube channel, and if possible, help me to share some of my videos in my YouTube channel or share the channel link. I'll see you in the next lesson.